So yesterday we went over the last homework on substitution elimination and that kind of thing. That kind of leads us up to this. It looks like they're two completely different things. And on this first lesson, it looks like they are completely different. In the lesson after this, we're going to see how they relate to each other. All right? You've done this. We did this together last year. Okay, when you had me for Algebra 2, we did this in Algebra 2. So let's talk about what a matrix is. All right, so matrices is the plural. All right, I'll put a PL right there for plural. So matrices is plural for more than one matrix. So one of these things is called a matrix. Tell you what, I'll just show you a matrix. There's a couple things I was going to write. We use these brackets right here to indicate a matrix, all right? And then the stuff that's in there, inside of there, is are the elements of the matrix, all right? So all the things that are going to be in here are the elements of the matrix. So the first one, normally you would put numbers in here and not a lot of letters. Sometimes you do have letters in here, and you got to solve for those variables, okay? You put an X and a Y or whatever, but they're just using this A1, B1 just to indicate just generally where the numbers would be located, all right? And then B2. All right, so that is a matrix. The thing to remember about a matrix are rows and columns. We have rows and we have columns. And that definitely makes a difference. These are your rows right here. So those are the rows. And these right here are the columns. All right, and it's important to know which ones are the rows and which ones are the columns for what we're going to do in a little bit. Since we talk about the size of the matrix. Let's talk about that, the size of the matrix. And it's how many rows by how many columns. All right, we use the X to represent the by, so rows, columns. So in this one right here, what is the size of our matrix? How many rows does this matrix have? It's got 2. And how many columns does it have? It's got 2. So this is a 2 by 2 matrix. All right, and that's pretty important as well for what we're going to do a little bit later, okay? I put some other ones in there. I put a 2 by 5 matrix. So a 2 by 5 would be 2 rows and what? 5, 1, 2, 3, 4, 5 columns. I'm not going to write it all in here, but you get the idea, right? You call this A1, A2, B1, B2, C1, C2, and so forth. If you wanted to put those in there, you can. I'm just trying to save some time. So that would be a what? A 2 by 5 matrix. Got it? It always goes rows, columns. The way I can remember that is RC. When I was a kid, I used to drink RC Cola. They still sell it, but they usually have like one bottle on the shelf in the grocery store. It's not as common as it used to be. We actually used to buy RC Colas from the gas station. We would go to a gas station. They'd have stacks of these little pallets, and they had a spot where you put a glass bottle in there, and it was a matrix too. It was like, I forget exactly what it was, maybe 4 by 6 or something like that. And so you'd have a certain amount of bottles in there, and it was in a wooden pallet, and you'd pick it up, pay for it, and you'd have a bottle of RC. And then when you're done with the bottles, they were glass bottles, you wouldn't throw them away, you take them back and you get money. You get like 5 cents for every bottle or something. And then you usually put that towards the next case of RC Cola. That's what we used to drink, RCs. My dad used to tell a story when he was a kid growing up in the hills of West Virginia. They would go to the local store, get an RC for like a nickel or something. He said they would never just open it and drink it. He says every time he ever remembered drinking an RC Cola, they would shake, he'd put his thumb on, he'd take the lid off, right? Put his thumb on it, shake it up, and then they'd like squirt it into their mouth. He says that's the way, he said every single time we drink an RC, that's the way he would drink it. I don't think I ever did that, but that's the story I remember my dad telling. Anyway, RC Cola. rows, columns. All right, there's my little dumb story for you. I just thought that was interesting. You may not care. All right, let's talk about things that are equal matrices. And this is kind of something that, what's the word I was trying to think of? Not self-explanatory. It's kind of intuitive. You ever hear that word? It's kind of intuitive. When I talk about an equal matrix or equal matrices, all right, I think it's kind of intuitive that you might be able to figure it out. So anything that has the same dimensions are equal matrices. So if you have, and by the way, I didn't name this earlier. If I have a matrix, right, and we'll call this A1, A2, B1, B2. Again, we'll do a 2 by 2. All right, there's other ones, but we'll do that. And we say B is also, we'll do this. We'll go C1, C2, D1, D2. Just to represent different numbers. It doesn't matter. All right. So these numbers inside, the elements don't have to be the same. Okay, it's the size of the matrix. Okay, if it's exactly the same dimensions, then they're equal matrices. All right, so the letters don't have, it's like this and this don't have to be equal to each other. You with me on that? To be an equal matrix or equal matrices. They just have to be the same dimensions. As long as they're the same dimensions, then they're equal matrices. This is a 2 by 2. This is a 2 by 2. They are what? Equal matrices. We're going to talk about that in a few minutes. We're going to do some stuff with that. Actually, we're going to do something right now with that. This is an example. They call this example 2. I don't know where example 1 went. I don't have example 1 written in my notes. Whoops. So I call this example 2. All right, it says find the values for x and y. So here's what they're going to do. They're going to give you a matrix. This matrix. Now, what are the dimensions of this matrix right here? So what by what? It's a 2 by 1. Very good. There's 2 rows, 1 column, so it's a 2 by 1 matrix. Now, if I said it's equal to, now what do you think? If they're equal to each other, what do you think the dimensions of this matrix has to be? It's got to also be a 2 by 1. All right, and this one they say is, 2x minus 6, and this one is 2y. You know what I said earlier about this not equaling this? I was completely wrong now that I think about it. Okay, if they were equal, if I said matrix A was equal to matrix B, if I said that they were equal, it's not just that they have the same dimensions, so I was completely wrong, but the elements are going to be equal to each other. So this A1 would equal the C1. This B1 would equal the D1. Does that make sense? All right, so sorry about that. I don't know what I was thinking, but that would be true. So yes, the elements in here would equal each other. So I'll take that back from what I said earlier. And this one obviously would be this one. They would be equal to each other. Everybody got that? Sorry about that. Not until I saw this, I thought, wait a minute, if they're equal matrices, yeah, all the stuff inside there have to be equal. All right, so what if you wanted to solve for x and y here? What would you do? How do I know what's equal to what? Well, this first row and first column, there's only one column, right? So this one has got to equal this. And this x has to equal that. So let's write that down. So y equals 2x minus 6, and x equals 2y. So how would you solve for something like this? We kind of already had a lesson or two on this. It's actually a pretty simplified version of it. What would you do to solve for x and y? Substitution, absolutely. Okay, so I'd substitute. So x is equal to 2y. So what I would do is take that, plug it in right there for that x. So y is equal to 2 times x, but x is 2y. All right, so y equals 4y minus 6. Let's do this. Subtract a y from both sides, that's a 3y. Add a 6 to both sides, that equals 6. Divide by 3, y is 2. Plug it back in for the y right here. So x is 2 times 2, which is 4. And there you go. There's your x, and there's your y. It's not really what this lesson's all about. What this lesson is about is this part right here. Just setting those elements equal to each other, okay? Does that make sense? Yeah, it's not so bad. I already said that matrices are named with capital letters. That was the next thing I had in my notes, but I said that already. So that's pretty easy. So let's talk about how to add matrices together. All right, so we'll call this the addition of matrices. All right, the key to adding matrices is they have to be the same dimension, okay? In order to add matrices, the two matrices have to have the same dimensions. So if one matrix is a 2 by 2, in order to add it to another one, it has to be a 2 by 2. All right, if one is a 2 by 5 and you're going to add it to another matrix, it has to be a 2 by 5. Okay, so in order to add or subtract, okay, I could put subtraction in here as well. Okay, addition or subtraction of matrices, they have to have the same dimensions. Was there a question? So let's add a couple together. Example 3. And they give you matrix A, and they call it -2, 0, 1, and 0, 5, -8. That's matrix A. And they tell you matrix B is -6, 7, -1, 4, -3, 10. 4, -3, 10. All right, there you go. All right, so this is what they give you, and they're going to ask you to find A plus B. So matrix A plus matrix B. That's what they're asking you to do. Should be pretty straightforward, I think. Again, I think this is very intuitive. All right, so what do you think? I haven't even told you how to add matrices together. I just said they have to be the same dimensions. So are they the same dimensions? Yeah, it's a 2 by 3. This is a 2 by 3. They're the same dimensions. So yes, I can add them together. All right, if they were not the same dimensions, you wouldn't even have to worry about it. Just say no. There's no answer. Okay, you can't add them together. So if I was going to add these together, what do you think I'm adding together? This and what? -6, right. Everything that's in the same spot, all right? So the -2 and the 6. So here's how I would write the addition of these together. I'm gonna write all this out. You might be able to just do this in your head, okay? But just for this teaching purposes, I'm gonna write it out. So it's gonna be -2 plus -6. Everybody with me on that? All right, so it doesn't matter what order you go in. I'm just gonna go across the row. So let's add the 0 and the what? 7, and then the 1 and the -1. Would you agree? Very intuitive. If I just told you to add those up and I never told you how to add them up, is that probably what you would have done? Yeah, that's probably what I would have done if I didn't know anything about matrices and I just said, okay, take that and add it to that. Yeah, I'd probably add all the things that are in the same spot, all right? What about this one? 0 plus 4, 5 plus -3, and -8 plus 10. The rest is just arithmetic, super easy. So that's -8, that's 7, that's 0, that's 4, excuse me, that's 2, and that's 2. And there you go. All right, and there you go. You've added two matrices together. Let's do another one. Let's do subtraction. This is example 4. So this time they give you different matrices. So they'll call this one C. Say this is 9, 4, -1, 3, 0, -4. What are the dimensions of this matrix? Anybody? It's not 3, 2. Don't say 3, 2. 3 what? 3 by 2. Okay? It's a 3 by 2 matrix. So 3 rows, 2 columns. It's a 3 by 2. We good? All right, let's do another one. -6, 1, What do you think we're going to do with these, since it's a different example? Think we're going to add them again? Yeah, we're going to subtract these. Okay, so let's subtract them. They're both 3 by 2s, so I know that I can add or subtract them together, correct? So this problem says to find C minus D. Now, you got to be very careful, especially with a minus, especially if you have negatives, all right? Especially if the second one is negative. That's where a lot of people go wrong. So if we're going to subtract these, what numbers am I subtracting? Start with that top left one. So 9 what? Minus 8. Everybody see that? They're in the same spot. We subtract them. They're both positive. Just go 9 minus 8. Let's move over. So this is going to be 4 what? Minus negative 2, right? That's where people could go wrong. Where do you think people would make a mistake on that one? I've seen it a lot because I'm the teacher. You might not have seen it, but where do you think a student might make a mistake? Yeah, I've seen that so many times. People just put 4 minus 2, but it's not. That would be addition, wouldn't it? All right, so it's 4 minus negative 2. Make sure that you do that. All right, just wanted to point that out. Negative 1 minus negative 6. 3 minus 1. Down the next row, 0 minus 5. And then negative 4 minus negative 5. And now we just work it out. It's just arithmetic, no big deal. 9 minus 8, that's 1. That's a 6. That's plus, that's a 5. That's a 2. That's a negative 5. And that's plus 5, so that's a 1. And there you go. Super easy. But subtraction can be just a little bit more complicated because it's very easy to mess your signs up. All right, so make sure that you do that. Okie doke. I'm down one page. Now I'm on my second page for my notes. So we've done addition, we've done subtraction. What do you think is next? Multiplication. Good. Now the first multiplication is a very easy multiplication. The second one that we do, the second multiplication, is the one that really you have to think about. Okay, it's not intuitive whatsoever. But this next one is, again, I think, intuitive. I think you can just look at it without me even saying anything, and you probably would understand what I'm talking about. So we call this, here's a word, I don't know, we might have used this last year. It's called a scalar product. If you take physics, a lot of times you talk about vectors, and then you talk about scalars. Scalar is just a regular number. It's just a number, all right? So if I'm going to multiply by a regular number, you could take a capital letter, which is a matrix. If I was going to multiply by a regular number, they use the letter K. It's a lowercase k, all right, but that represents a scalar. All right, so K times A. A is not just any old number. What is it? It's a matrix, right? K is just a regular old number. So how do I take just a regular number and multiply it by a matrix? It's very easy. This is a matrix, so it's got a bunch of elements in there. So I'm going to take this thing on the outside of that matrix, just multiply it by everything inside of the matrix. That's what scalar multiplication is. Or scalar product. It's very intuitive. I keep using that word, but that's the best word I can think of. So let's do example 5. All right, so they tell you that matrix A is this. This is a 3 by 3. So it's negative 4, 1, negative 1. Make sure you put a little space in between these. Don't jam up those numbers like right next to each other. Put a little space. We don't put commas or anything, but just make sure you leave a little bit of space in between so you know they're separated. It's negative 3, negative 1, and 8. Okay. So, first problem says find 3a. What does that mean? It means take a 3 and multiply it by matrix A. Everybody see that? Pretty straightforward. Tell you what, since I've already written this down, I'll just take this, copy and paste. Shoot. if I can grab that thing. There we go. All right. So, it's kind of ugly right there, but you get the idea. So there's my matrix A. How do I multiply it by a 3? Well, I'm going to put a 3 right on the outside. So again, without even me telling you, I bet that everybody in here could figure out how to multiply that together. What would you do? Take that 3 and do what to it? It's kind of distributed. It's not really, but multiply by every single element in here, okay? So everything in here is just being multiplied by a 3. That's all it is. Again, very simple, very basic. The next thing we're going to do is not that simple, is not that basic, all right? So let's do that. What's this going to be? Negative 12, 3, negative 3, 9, 21, 0, negative 9, negative 3, 24. There you go. Have we done anything remotely difficult yet? Not at all. Especially since you learned this last year. All right, we've got a few minutes, so let's do this. So now what we're going to do is we're going to do multiplication again, but we're not going to multiply a matrix just by a regular number, a scalar. What do you think we're going to do? We're going to multiply by another matrix, exactly. So we're going to multiply 2 matrices together. Now remember on addition and subtraction, what had to be true about both matrices when you added or subtracted? Same dimensions, exactly. Okay, that is not necessarily true with multiplication of 2 matrices. Okay, I will give you a little example. So if I was to multiply matrix A, remember we use capital letters for matrices, so anytime you see a capital letter, that means it's a matrix. So if I take matrix A and multiply it by matrix B, you got to look at the dimensions. That's why it was important at the beginning to know rows and columns. All right, so make sure that you understand how to find the dimensions, because that'll determine if you can multiply them together, because you can't just multiply any 2 matrices together. There has to be something true about those matrices. All right, so let's say matrix A was a 2 by 3 matrix, and let's say matrix B was a 3 by 2 matrix. Now, are they the same dimensions? They both have a 2 and a 3, but does that mean they're the same dimensions? No, this is 2 what? 2 rows and 3 columns. This is 3 rows and only 2 columns, all right? What we look for is this. I'll put this in red so it pops a little bit. We look for the 2 in the middle. Are those 2 in the middle the same? They are. That means that we can multiply those together, all right? Everybody see that? So that's what, and the order that you multiply your matrices in can be important as well. All right, so you always look for the 2 in the middle. That's how I always do it. I put them side by side. I look for the 2 right here. Are they the same? All right, is this column and this row the same? If they are, then I can multiply them together. There are times when that's not going to be true. So if I had a 2 by 3 and then a 4 by 1, can I multiply those together? No, because I look here. Are they the same number? No, they're not. I cannot multiply a 2 by 3 times and multiply it by a 4 by 1. Make sense? All right, so this won't work. Don't even try it. You just know right off the bat you can't multiply them together. But if these 2 are the same right here, that's fine. Now, did the outside have to be the same? No, this could have been a 3 by 3, and I could still multiply. It could have been a 3 by 4. It could have been a 3 by anything, and I still could multiply those together, right? It's these right here. This column and this row, right? The column of the first matrix and the row of the second matrix have to be the same. To me, saying that is too confusing. Visually looking at this makes it a lot easier. Would you agree? All right, so let's do skip that little bit. I don't think that's super important. Let's go right to an example and do one. Let's turn this back to white. All right, so here we go. At least this year, this is our first multiplication of two matrices. You may not remember it from last year. I bet you some of this will come back to you. I probably wouldn't expect you to remember how to do it exactly. Give you another one. C. This is 6, -1, 4, 2, -2, -1. All right, there we go. They're going to ask you to do different things. We may probably only get to the first one. Maybe we'll finish these up tomorrow after you take the quiz, okay? So this is part A. They ask you 3 things: part A, part B, part C. So let's just do part A. Actually, we can do A and B today. So first one says find AB. What does that mean? We're multiplying matrix A times a matrix B. Just put it up there. What's that? Can you what? I can't hear you. You got to speak up. Can I fill out a test? Yes, but put your test up there. All right, so here we go. What I'm going to do is I'm going to copy and paste them, put them right next to each other. Oh, come on. There we go. All right, there's that. And then there's this. First thing that we do, very first thing we do is we have to determine, can we multiply them together first before I even start multiplying them together? Put a little dot in the middle for multiplication. So what I'm going to do is figure out the rows and columns to both of them. Connor, what's the reason you got your laptop open? Okay, because really I don't think there's any need for a laptop on this. You got a book, right? You got notes in front of you, right? You don't even need the book, to tell you the truth. So why don't you take some notes on this by hand? All right, here's what we do. Everybody watch. Let's put this in a different color. You may remember this. So first of all, let's see if we can multiply them together. What is this? It's a 2 by 2, correct? And we're multiplying it by a what? 2 by 3. 2 by 3. So where are we looking? Right there. Are they the same number? Yes, they are. Can we multiply those together? Yes, we can. So let's do this. So watch very carefully. What we're going to do is we're going to take this row and this column, and we're going to do some things with it. We are going to do multiplication, but we're also going to do a little bit of addition. Okay? So let's do this. Let's write it down underneath. Might be easier. Equals. So what we're going to do, we're going to have a big, oh, by the way, do you see what's left over on the ends? 2 by 3. That's the dimensions of our answer. So our answer is going to be 2 rows and 3 columns. Everybody see that? All right. So here's what we do. We go 7 times 3. And I'm going to write it all out so that you know what we're doing. See what we're doing? You're taking that first one and that first one. You're multiplying them together. Then you're adding the other 2 numbers. 0 times what? What's the only one we haven't used yet that's marked in red? 5. That's going to be our first element in our matrix. So we go across the first row, down the first column. Everybody see that? So we do multiplication and addition. I multiply the first 2, then I jump over here, multiply the second 2, add those 2 up, and then I'll get an answer for that. You good? So now, what I do is now what I'm going to do is this. I'm going to stick with the same row, but now I'm moving to the other column. So this is a little, after a while you get used to it, but at first you really got to think about it. So now I'm going to do the same thing here. So what am I going to multiply? 7 times, oops, and red, don't want red. What am I going to multiply? 7 times what? Nobody's talking to me? 7 times negative 3 plus, what are my other two? 0 times 4. Okay? Then what do you think? We're going to do the same thing, but we're going to take that first row again, and then I'm going to multiply it by the third column. Let's do the same thing. 7 times 6. Oops, keep forgetting to turn it back to white. All right, 7 times 6 plus what? 0 times negative 2. Everybody good? Now what do you think we're going to do? Now that we've gone all the way to the end, I'm going to start again. But this time, instead of using the first row, what do you think I'm going to use? Second row. So now I'm doing this. And we're just going to repeat the same type of pattern, just with different numbers now. So now I'm doing what? 5 times 3 plus, then jump over to the next one, this 3 times this 5. Then we go to the second column. And we go 5 times negative 3 plus 3 times 4. You getting the hang of it? Yeah, after you do this a few times, you start understanding what we're doing. Okay? Now we go 5 times 6 plus 3 times negative 2. There we go. Remember what I said the dimensions of our answer is going to be? It's going to be what? 3 by 2, right? I'm sorry, 2 by 3. Sorry, 2 by 3. 2 by 3, right? Would you agree that our dimensions are 2 by 3? Yep, 2 rows, 3 columns. Now, we just do arithmetic now, so we can just figure that out. That's a 0, that's 21. This is a 0, that's negative 21. This is a 0, that's 42. This is 15 plus 15, which is 30. This is negative 15 plus 12, which is negative 3. This is 30 plus negative 6 or minus 6, which is 24. And this is your answer, just like that. All right? Just got to get used to that way of multiplying together. A lot of times, let me drop the mic here for a second. A lot of times I like to use my fingers when I'm doing it on paper. I like to start here, and what do? You go here, then you go here. You with me? And then you jump over to the next column. Left hand stays on that same row, and you go here and here. Jump over here and here. You got it? Adding in between. Same thing here. You start here, you go bang, bang, right there, right here, here, here. Once you get used to that, then it's actually pretty simple, all right? I'm not officially giving you homework tonight. I'll give it to you tomorrow, but if you want to start on it tonight, I mean, we're pretty much finished that lesson, all right? So if you want to get started on it, after the quiz tomorrow, I'll give you time in class to finish the homework. I don't have it in front of me. I gave you lesson plans, didn't I? It's 15 to 47 odd. 15 to 47 odd. It's just the odds. The first bunch, probably super quick and easy. So it's 15 to 47 odds. So that's why I said you should start on it tonight. This is section 2-3. So I'd do as much tonight as you can. Tomorrow, if you finish the quiz early, you can start it in class, finish it tomorrow. So that's plenty of time. There should be no complaining about doing all those problems, because there's really not that many anyway. It's only, what, like 15, 16 problems, something like that? All right.